Okay, safety. We are on the last one. Many dangers. In fact, if we put this as the first module, everyone would run screaming from the room. So there are high voltages for antennas, high currents because we use batteries. There are electromagnetic fields, and there are electromagnetic requirements that are part of your license. At 10 watts, the electromagnetic requirements are pretty negligible, but at the higher powers, yes, they're negligible. Higher sound levels, if you wear headphones and the volume's all the way up, you could damage your hearing. Antennas are usually on roofs, so you're working at heights, and you're working with batteries, which have got chemicals. Electrical safety, so it's the current that kills you, not the voltage. Anything over about 12 milliamps can do damage and potentially kill you. 240 volts can well and truly supply 12 milliamps, but hopefully in modern installations you've got an RCD, so residual current device on, so if you perchance do connect with the mains, it switches it off within a period of time. Older equipment, you need to be aware that older equipment may not be up to the same standard as modern equipment from a safety point of view. Valve equipment uses really high voltages, much higher voltages than mains, and the subsequent currents as well. Now, necessary to check local requirements. Some states allow unqualified practitioners to work on mains. This includes leads and plugs and sockets, etc., etc. Frayed and damaged power leads. Always be aware that if there's something that looks dodgy, it probably is and could be dangerous. So get somebody who knows what they're doing to resolve that. RCDs and earth leakage circuit breakers. These are most often in switchboards, so if they're tripped, you need to go and find your switchboard and reset them. And all approved mains operated devices will have a label on them that has numbers to say that it's certified, it is the CTIC, etc., etc. And it's good to have a clearly marked switch in your shack to switch off all your equipment in case you yourself get electroluxed and the family needs to know how to switch things off, and either that or knows how to go to the switchboard and switch everything off. So it's really good to actually have those all those switches clearly marked. As a rule of thumb, always treat things as they're live and they're dangerous. There's a thing about using valve equipment. It's a bit of a rule of thumb. Whenever you work on valve equipment, you always have one hand behind your back, so that you can't actually connect one hand to the voltage and one hand to earth, because that's a dangerous path through your chest. Stops your heart. So you always work with one hand behind your back. Look up and live. When installing antennas, there are overhead power lines. Antennas are usually long, they're usually conductive. Never remove a safety earth. It's on there for that reason. It's a safety earth from a piece of equipment. And fuses. Always replace fuses with the same sized fuse and the same type of fuse. And if the fuse keeps blowing, there's a reason that you need to find. And fuses are current devices. They blow past a certain current level. They're not voltage devices, they're current devices. Protective earth. Now, for those who don't know, the protective earth is the straight one on the bottom of the PowerPoint. It's usually a green with a yellow tracer. Or just green in some older installations. Should not be removed. A lot of power supplies have a 3-pin plug, but a lot of devices also are what we call double insulated. which means they only have 2 pins. They only have those 2 pins because they're actually have 2 layers of insulation associated with them. They don't have an earth pin, and that's quite valid. And obviously, never connect earth to gas pipes. And the stupid thing about that is most gas pipes these days are plastic anyway. So they do have metal on the inside, but they're plastic on the outside. Here's a scenario, interesting scenario. The boy has obviously been electrocuted. Assume the circuit is still alive unless you've turned off the switchboard. He's in rubber shoes standing on a phone book. Now, I don't know where you get a phone book from these days because phone books don't exist. And I hope that the handle of the broom is actually wood, not metal, which they usually are now. So, but you get the point. It's live. Don't put yourself at risk. And in fact, follow the doctor's ABCD, which is the Resus Council's steps. Check for danger. Don't put yourself in danger. Don't potentially electrocute yourself. Response, if they are responsive, then if they're not responsive, send ring 000, open an airwave, look for signs of life, so whether they're breathing or not, whether you've got a pulse. Give 2 initial breaths. Now, I actually think they've taken that out. They've actually taken that out of the Resus Council's. There's no more breaths. It's just chest. It's just chest compressions now.
The idea is that if your heart's going, then you'll breathe on your own anyway.
So 30 chest compressions, forget the breaths. Just keep going with the chest compressions until, hopefully, the ambulance turns up. And if you've got an AED available to you, so an automatic defibrillating device, take it out of its box and it starts talking to you. It starts telling you what to do. So yeah, and continue CPR until qualified person or ambulance, etc., or life signs return. Batteries, they are chemical devices, so you need to be very careful of them. Especially, you only need to go to YouTube, look at the LiPo battery explosions. They're rife with scary explosions of batteries. You don't short circuit it because they can supply an awful lot of current very quickly. Always replace the fuse. Electromagnetic radiation. There are electromagnetic radiation requirements as part of your license. It's in the class license. One of the key things here is you need to keep your distance from things that radiate, namely antennas. So safe distance, an example, quarter wave antenna. The very top of a quarter wave antenna when you're transmitting is actually pretty high voltage because of the nature of a quarter wave antenna. It can give you an RF burn. And so, yeah, you need to be aware of that sort of thing. If you're using particular types of portable antennas, you need to know that the ends of them have high voltages on them when you're transmitting. Even with 10 watts, there is reasonably high voltages. Safe distances, and safe distances for not only you, but obviously the family. If you're putting an antenna in the backyard, you need to be aware of that. So put them up high, put them away from where people and children play. Slips, trips and falls, cables in shacks, lightning. You really probably do need to disconnect your antennas or connect them to earth. There is an earth setting on a lot of antenna switches. Headphones and loud noises, voltages and currents we've got into, and RF earthing. So if you've got an RF earth, please use it. And look up and live with antennas. Some questions. Fuses are in place in circuits to protect against. They're a current device, so they will blow when they get to their threshold. Actually, they won't blow when they get to their threshold. They'll blow when they get past their threshold. They will actually sit and quite happily operate at their threshold. Batteries should be disposed of correctly because environmental issues, the chemicals that in them can cause,
Explode or have fumes that punctured.
especially if they're lipo. Protective mains earths.
Can only be removed or replaced by qualified person.
Number C, can only be removed or replaced by a qualified person. As well as EMR risks when working around functioning antennas, another significant danger is... Now, where are antennas normally? They're on roofs. You're at height. So you need to be aware. High voltages and currents can be present around operating antennas. It is important that
People and animals are kept at a safe distance.
distance, keep them away from those operating